Out of all the computers here at Retro Computing Ranch, I'm currently just fired up about the AT&T 3B2. It's a fantastic machine. It's quirky, it's weird. It's not an x86 beige box. It's not consumer grade. It has a lot of stuff going for it that has a pretty good cool factor. But there are some challenges. And we're going to take a look at some of those challenges today. But I think that before the day is out, we're going to have a big breakthrough and we're going to get a lot of satisfaction. So stick around and let's dive in. Among my collection of AT&T 3B2 computers, I have a /300, another /300, and a /310. Unfortunately, I only have one working MFM hard drive that was included with those machines. So I decided to get out my collection of MFM hard drives from over the years and see what was working in the collection. Now, I've gathered them up over time, but I've never really tested them because I always prefer to use an XT IDE. But in the case of the 3B2, there's only MFM support built in, and there's no way to add an XT IDE. One of the drives during power on testing failed spectacularly. Now, given that this drive appeared to be a total loss, and I could hear grinding noises from inside of the hard drive enclosure, I decided to open the hard drive enclosure to see what was going on. I knew that there was no risk of further damage because there was already metal shavings floating around inside from the grinding. Once I removed the cover, I was able to see that one of the hard drive heads had come loose and had been dragging across the disk surface. I don't know if this happened during first power up because of stiction or if it had already been that way. Other drives displayed issues like spinning up and then making strange noises but never coming ready, such as this ST225. I also was beset by drives that would spin up like they were going to work, but then would almost immediately spin themselves down. I also had drives that would spin up, flash their activity LEDs, and appeared to be working, but still generated the same disk sanity failure. And yet another drive that would spin itself up and then almost immediately spin itself down. There were also several drives that showed no signs of spinning themselves up at all. All right, so what we have set up here, just to my right, I have the AT&T 3B2/300 that we got working in a previous episode. I'm going to fire it up, and we're going to run a benchmark program on it that will let us determine what the floating point performance is of the stock system with no math acceleration unit. So just whatever performance we can eke out of the Western Electric 32100 CPU. I'm going to go ahead and hit the power switch. And we're in self-check. So here in just a few moments, we should get the diagnostics message. Now on the 3B2 300 series, the diagnostics are on the hard drive. So if we see the diagnostics message, that means that the hard drive is working. Now I know that it works on this machine, but that's something that we're going to be taking a look at on the /310. So when we boot that system up, if we see the diagnostics message, then we know the hard drive is working. And there's our diagnostics message. So it will run the diagnostics test off the hard drive. It will say whether or not they have passed. If they passed, it will continue execution. All right, so here's our Unix splash screen. Now, as we continue the boot up, it will tell us, well, it's already told us how much RAM we have. So we have 2 megs of RAM with a little more than 1.3 available. It's also going to tell us momentarily what hardware we have in the system. So it should tell us we have a system board, we have a floppy drive, and we have a 72 megabyte hard drive. Now we do want to make sure that we take a look at that, because when we do start Unix on the 310, it should tell us that we have the system board, the floppy drive, the 72 meg hard drive, and a math acceleration unit if the math acceleration unit is working properly. Okay, so you can see here on our system configuration, we do have the system board, the floppy disk, and the 72 megabyte disk drive. So in a few moments, we should be getting our console login prompt. There we are. So we'll log in with our normal user. And there we go. So the first thing we're going to do is just SU. That gets us to the super user account. It's not best practice, but this system is air gapped, so I don't see it as being a big security risk. We need to mount the floppy disk that's currently in the GoTech so that we can get the C file and compile it for the benchmark. So we're going to do a mount /dev/DSK/ I think this is C0D0S5, and we're going to mount that onto install directory. We got no errors, so it probably worked. Let's do a df to make sure. Okay, great. So we can see that there. Let's go ahead and cd to our user one's home folder, and I spelled that wrong. So now we have the floppy disk mounted, and we need to copy over the benchmark C file so I can compile it on the system. We're going to use the cp command to do that. It's /install and flops b.c. I've gone through a couple of revisions of this. Should copy it over. There we go. So let's do an ls. And I can see it there. So we're going to compile it. The way that we're going to do that is with the cc command. So cc space -o space flops b, and the C file is flops b.c. This will take just a few moments to compile. And after a sufficient amount of time waiting, we're back to the system prompt. So we can go ahead and execute the program we just compiled. /flops b. So we're going to do the addition test first. And let's make a note of where we are at with system performance. Now, of course, it does take a while, as any good benchmark should. All right, there we go. So our performance on the addition test is 2,114 floating point operations per second, and it core dumped. So this program did run correctly in the emulator, so there's a difference between the emulator and the actual physical hardware. Let's see if we get the same performance with the benchmark if it does the same core dump when it actually has the math acceleration unit installed. So we're going to go ahead and shut the system down and swap the hard drive over to the other machine. We want to make sure we protect the image that's on the hard drive. And we're going to do that by shutting down correctly. Now, to do that on System 5 Unix, you have to be super user and you have to be in the root directory. So we're going to do a cd space /. So we're in the correct directory now. And then the command to shut the system down all the way is shutdown space -I0 space -G0 space -Y. Now, I is where you're setting the run level. So I0 is complete shutdown. I6 would be a reboot. I1 would be single user mode. There is a shortcut. You can do shutdown space dash Y, and that will also put you into single user mode. So we're going to go ahead and initiate this. We'll get a message that shutdown has started. Then there'll be a broadcast message to the system with a system bell. There we go. So now we just need to wait until the system finishes shutting down, and we'll be ready to swap the drive over and see what happens. All right, so now we've received the system is down message. The unit just powered off, the drive is spinning down, and there we go. So I will be back as soon as we get the drive swapped over into the 310 chassis. So we're back. I've got the MFM drive that was in the 300 chassis swapped into the 310 chassis. We're ready to go ahead and start up and see if the onboard MFM controller in the 310 board can talk to the drive that was low level formatted on the 300 system. I don't know if this is going to work. We're going to find out. If it doesn't work, we'll be doing a full reinstall of Unix on the system, which is not bad, but it does take a while. So I'm going to go ahead and reach over and hit this power switch. We'll see what happens. All right, drive is spinning up. Now on this system, I do not have a working battery. So that's why we got an NVRAM sanity failure. Our tell on this is going to be if we see a diagnostics prompt, then we're going to know that it's talking to the hard drive. Because like I said earlier, the diagnostics are in a partition on the hard drive. And so if the system can't read the hard drive, it never executes the diagnostics. Crossing our fingers here, hoping that this fires up. I'd really prefer to not reinstall Unix. I think the last time I did it, just for the base system, was about an hour and a half, hour and 45 minutes. And then everything else I did across 2 or 3 evenings, working at it probably a couple of hours at a time. Package management based off of floppy is just slow. I wonder if it takes extra time when the NVRAM has been reset. Yes! Okay, so we got diagnostics. That means that the main board in the 310 is talking to the MFM drive, and things are working well enough to be able to access the disk. Okay, so here in a few moments, we should be getting our Unix splash screen, and then we'll see what happens from there. Okay, we got our Unix splash screen. Oh, and look at this. It's even better. This 310 has 4 megs of RAM in it. So we've doubled the amount of RAM that we have available to us. So we have just a little over 4 megs of RAM in the system, a little over 3 available. Things are looking pretty good. It didn't do a disk check, a file system check. So it seems like it feels confident that things are working. Now, next we should be getting our AT&T 3B2 system configuration. So what we're looking for here is to see if we have a math acceleration unit or not. I know there's one in the system, but I want to see if it shows up here. It should. Okay. Yes. Great. It's okay. So we're seeing here that we have 4 megabytes of RAM. We're seeing that we have a math acceleration unit installed. That's all excellent news. So now we just have to wait for the system to finish booting up the rest of the way, and then we could do some testing. Okay, here we go. Getting close. We should be getting our console login prompt any time now. There we are. Okay, we're going to log in as user 1. Okay, there we go. Go ahead and promote ourselves to super user and move into user 1's home directory. And then we're going to run the flops. Nope. We're going to run the flops B benchmark. I'm just so excited about this working that I'm having a little bit of trouble focusing here. Okay, so previously when we ran this test in the 300 chassis, we had a floating point operations per second of 2,114. So let's see where we come out at on this test now. Okay, so 8,421. That's quite an improvement. That's great news. It's still core dumped. So I'm going to have to see if I can figure out what's causing that in the code. But so far, this is great news. Let's take a look at what else I have in my directory here. So I did work this up the other day. I had some curiosity as to what libraries, what header files for C that I actually had in the system. And I've been playing around with coding large language models. So I had it do a few things for me, and I want to see what this does here. So we're going to do HD renum. And that tells us what our available header files are for C. Now I know that I could have just looked around in the system and used ls to find all this information, but why not have a program that does it for me? I also have a program here. It's called 8 Queens. It gives all the solutions to the 8 Queens problem. So we're going to do a quick compile on that one. And we spelled it wrong, but that's fine. I still haven't looked into what it's going to take to get the backspace issue sorted out here. So we have to give it a few moments to finish the compile. I need to dig up some documentation and see if I can make this more verbose. I'm used to the way that Linux does it, where it just kind of tells you everything. This is the old Unix way, where if you don't get a message, you can just assume it's working. All right, so there we go. We have all 92 solutions to the 8 Queens problem. All right, so let's go ahead and demo a program that I wrote that will help ham radio operator calculate the length of a dipole antenna, half-wave dipole. Now, part of the reason for this is that I'm also a ham radio operator, and I have a YouTube channel where I do ham radio stuff. That channel is called Bootstrap Workbench. So go ahead, if you're into both, go ahead and stop by, take a look, see if there's anything you like over there. So this program wants us to enter a frequency in megahertz. So I'm going to enter 1.840 and hit enter. And it gives us all the information in feet and meters to construct a half-wave dipole antenna. All right, so we're in a good place. We're not as far as I would like to be, but we do know that we have 2 working 3B2s. We only have 1 working MFM hard drive, but that MFM hard drive is now in the better of the 2 machines. So we have a math acceleration unit. We have 4 megs of RAM. That's going to give us some more capabilities. Future me is going to have to figure out how to repair MFM hard drives or come up with an MFM emulator. We'll see where that goes in a future episode. For today, I want to thank you for watching. I really appreciate you being here, watching until the end. Make sure to like, share, subscribe, and have a great day. We'll see you soon.